let's take a look at finding all the zeros. Now, when I say all the zeros, I mean rational zeros as well as complex zeros. Complex zeros, I mean in the form of a plus bi. As you know, if a plus bi is a zero, then its conjugate, a minus bi, also has to be a zero. So let's take a look at this problem. We have a third degree polynomial and we want to find all the zeros. Again, let's first make a list of zeros here. A list of possible zeros. P, our constant term, is 13, and Q, our leading coefficient, is 1, which is kind of nice, and especially with 13. So, well, let me write down. 13 is P and Q is 1. So if we want to find all the factors of 13, there aren't many. There's just 1 and 13. Of course, 1 is just 1 times 1. So we're basically done with our list. It's kind of nice. We narrow it down to 4 possible numbers. One of them must be a 0. So, well, let's start with 1 and see what happens. Definitely do not use 2, because 2 is not in my list of possible zeros. So 2 would not be one of the zeros. Keep that in mind. Okay, let's write out the coefficients of this trinomial that is in descending order from the highest exponent down to the lowest. And there's also no missing term, so we start with 1, -5, 7, and 13. Okay, again, if you sit at home and you start this, you go ahead and you start with 1. So let's start with 1 and see what happens. You always bring down the first coefficient. 1 times 1 is 1, plus a -5 is a -4. -4 times 1 is a -4, plus 7 is 3. I can already stop here because I can see that I do not get 13, a remainder of 0. So, okay, I only had 4 possible choices. I picked the wrong one, so the next value in my list would be a -1. Okay, so let's try -1 and see what happens. Let me just change the signs and then I can just, anyway. We bring down the 1. -1 times 1 is a -1. Now if we add those two numbers, that gives me a -6. -6 times a -1 is a +6. I'm just going to write over it. And look at this, 7 plus 6 is, 13. Here you go. And 13 times a -1 is a -13. And guess what? My remainder is 0. So now we found our first 0. We bring our 1 degree less polynomial back with the variables. So the coefficients are right here with 1, -6, and 13. X squared minus 6x plus 13 equals 0. You can clearly see that I cannot factor this trinomial. Now I'm going to have to use the quadratic formula. Who remembers the quadratic formula? A is 1, B is -6, and C is 13. X equals opposite of B, so that would be a +6 plus minus square root of B squared, which is 36 minus 4 times A, 1 times C is 13, all over 2A, which is 2 times 1, which is 2. Okay, we get 6 plus minus 36 minus 40, 52, all over 2. Now 6 plus minus, we have definitely a negative 16, negative 16, yes. 36 minus 52 is a negative 16 all over 2. Oh, look at that. We simplify further. 6 plus minus the square root of negative 16 is 4i all over 2, and I can squeeze the answer right here. Now we're simplifying. We are dividing the 2 into the 6 as well as into the 4i. 6 divided by 2 is 3, plus minus 4i divided by 2 is 2i. Here you go. This is a complex answer solution. So all the zeros, I can write them in here. These zeros of this polynomial, negative 1 was the first one. And if I separate this expression, I get 3 minus 2i and 3 plus 2i. And you can see those two are conjugates of each other. So conjugates, I always say, travel in pairs. If you have one zero, which is of complex nature, then the conjugate itself is also a zero, which is a perfect lead-in to this last problem I want to show you here. Now we're finding a polynomial. This polynomial, so basically, I want to find the polynomial in expanded form that has a degree of 3, and the zeros are 2 and 3i. I only gave you 2 zeros, so where is the third zero since my polynomial is of degree 3? Well, that comes from the fact what I was just talking about. If 3i is a 0, then guess what? Its conjugate must also be a 0, which would be negative 3i. This is not given to you. You have to remember that. So be careful about that. Now what do we do? Well, these are my zeros. I want to write them now as factors. So if 2 is a 0, then my factor is x minus 2. Remember, a little sidebar over here. If I said x minus 2 equal to 0, I get a positive 2. So if I write it as a factor, I have to have the opposite sign. Times x minus 3i times x plus 3i. This is my polynomial, let's call it p of x, in factored form. I want to expand it, and I want to give you some advice. You want to multiply the x minus 3i and the x plus 3i first. The reason being is because the i's actually disappear, and you will see that in a second. So let's just multiply it all out. X times x is x squared. X times 3i is plus 3xi, which way you write that does not matter. Then we multiply minus 3i times x, which is a minus 3xi. And we have a minus 9i squared. Combining like terms, you can see that these two cancel out. You also need to remember from some previous math class that you have taken that I squared by definition is negative 9. So this becomes negative 9 times a negative 1, and no more I in my expression here. X squared plus 9, if I simplify it all, this now needs to be multiplied, don't forget, by x minus 2 factor. Okay, we multiply again. X times x squared, there is my third degree polynomial, plus 9x minus 2x squared minus 18. If you want to write it in descending order, go right ahead. So our official polynomial is x to the third minus 2x squared plus 9x minus 18. Beautiful. Here you go. Done you are.